Today we are going to talk about the event search at StubHub. And is Mayank?
So my name is Mayank, and I'm the lead product manager with StubHub. I work with Gopal on the search and discovery team at StubHub. We are going to talk to you about event search at StubHub, and we actually have a very packed agenda. So
Today we are going to talk about more about the search at the StubHub, how we use search at StubHub, and what are the many use cases are solved at the StubHub. But in particular, we'll talk about more about the event-specific search at StubHub, and some of the relevancy methods we use to improve the relevancy to show better results for our customers. And we're going to talk about some of the machine learning technique we are using it, and some of the queries, natural language queries we are supporting actually on our sites, and some chatbot use case. And finally, I'll go over about high-level system designs about our search infrastructure.
now, before we go over all that we are going to talk about, right? I just want to mention quickly about what is StubHub, right? So StubHub is the world's largest ticket marketplace, right? We have tickets for over 10 million events. Our idea with StubHub is to actually create a safe marketplace between buyers and sellers so that buyers and sellers can buy tickets safely. And one of the things that StubHub did recently was to actually buy TicketBiz. So we acquired TicketBiz. It's a pretty global company, and we are going to expand ourselves into 40 different countries. That's our goal. And in order to expand, right, we actually rely on our partners. So in North America, we have partnered with MLB, NFL, pretty much all the major leagues. So that's what StubHub is all about. Next up is actually about how StubHub, how search drives everything inside StubHub today.
Yes. So as I said, right, StubHub search drives everything. I think it is pretty much true for a lot of e-commerce sites. Actually, search is a pretty heavy-driven use cases. But on our side, actually, 70% of the people who come to our site, they conduct search. So when they conduct a search, if they don't find things, they cannot buy those items. And so that's actually the pretty challenging job we have. And we are using search. I think a pretty search plus like a Solar from like 2010 from Solar 1.2, and right now we are on like Solar 5.x. We are looking for going upgrade to the 6.x or something like that. But the idea was like, what are the use cases we solve or the search actually power at the StubHub? It's like a catalog search, which is like you're searching for events, performers, venues, and there's a ticket search, and there's a NoSQL use cases like managing inventory and the sales for the brokers. So as you can see, like the search drive use cases like before the buying experience and after the buying experience, a lot of things actually drive by the core search engines. And some of the use cases I talk about at the home page, you can see there's no actual search queries happens, but you can see the results actually showing from actually a search engine, which shows events for popular events in your locations, which is pretty much a geo-based search, because here you can see that there's a user context about the location. So we know the user location is user in San Francisco. We show things about what's popular in the San Francisco. And other one is the regular search queries. You type search queries, and we try to show you relevant results. Other use case is about the browse. The browse use case is more tailored towards the team or the artist. When you can see all the events, which is powered by search engines, and it's sorted by the dates. On the right side is more interesting. There is no search actually queries happens, where you can see the list of the listings we show, which has the tickets. That's all also powered by search engines, which is pretty much very near real time, because as you know, actually when there is a high demand, the tickets are selling so fast, so we have to keep up to date with the listings should be disappearing from the site. And there's a venue map. You can see actually, because a lot of our users actually hover on the venue map, and they actually try to find tickets in which section the tickets or the zone is available, and what are the minimum price or maximum price on those zones.
Next up is actually what we do specifically within the search engine at StubHub, right? So our goal with our search engine is to show the most relevant event on the top of the page. That's a simple and basic goal, right? Now, on the left-hand side, you see the results from our previous search algorithm. On the right-hand side, you see the results from a new search algorithm. Actually, sorry, it's the other way around. So On the right-hand side, you actually see the results from our old search algorithm, and on the left-hand side, you see the results from our new search algorithm. Now, what is the difference? When the user types in warriors, right, on the right-hand side, you actually see the results from Santa Cruz warriors, Golden State warriors, and parking passes, right? It's just a simple text-based search. You type in warriors, whatever we have, we show the results sorted by the date, right? But on the left-hand side, something else happens. First, step number one, right? When you type in warriors, we go and predict what is the user really looking for. Is the user really looking for Santa Cruz warriors, or parking passes, or Golden State warriors? So we are able to predict, based on the query of the user, what the user really wants for that particular geo area, right? So for example, if the user types in warriors now, and the user is in San Francisco location, we will predict that the user is most interested in Golden State warriors. And then we go into the Golden State warrior list of events, and then we retrieve all the events, and then show them on the top of the page without parking passes. That's the most basic thing that you would see, right? Now, what if the user was in New York, and the user was to type in Giants? In that case, we would show him New York Giants. If the user types in Giants in San Francisco, he would see San Francisco Giants. So it depends upon the context. It depends upon where the user is. And then based upon that, we can predict and then show the most relevant result on the top of the page. So that's the most simplest thing. Now, how is that possible? So before we go into the how, before we go into the new engine, right, we can just show you really quickly what we had before.
So this one you can see actually is pretty much a very standard scoring and ranking methods most of the search engine people use. We try to use the exact match before the prefix match, so because exact match has a more weightage. And whenever there is a phrase query, we try to use the distance between those queries to make sure actually queries which appear in a closer distance, those are actually shows more relevant better actually. And the standard scoring model our is a TF-IDF, which is a default from our Solar search engine. We did not modify any of those. But we use the Dismax query parsers to boost certain fields. We use the minimum fields, which is minimum match, what the percentage of the query terms should be matched, and the query fields and the phrase fields. We do have external field approach to sort some of the search results, like popularity or the sales. And the way we sort actually, because we had one challenge actually, because our data actually, you have events which not changing much a lot, but we have tickets which changed a lot, actually their pricing changed a lot. So because when you go to the our use cases, you will see there's the event and there's what's the mean price and what the tickets available, some of this. So, but those data change a lot. So we have separate collections, and what we do actually during a search query time, we do a join. We use some of the patch submitted by the Solar community, which are like a value source joins, and there's a hash join plugins. And that's what we use right now. And the new one, so earlier the focus was scoring and the ranking to achieve at certain relevance levels. But without having a query intent, it's very difficult to have very good balance of the relevance itself. So in terms of the query intent, actually the query intent is like, about like understanding the user queries, which is very different than the scoring and ranking. Actually, the query intent happened, the query understanding happened before the search queries went to the search engine, which basically scores and rank the results, right? And but this changed the focus for all the search engine developers. Oh, I need to focus on the search query itself, not the scoring and the ranking. And but to understand the search query itself, actually it is important to put the more ground on understanding on the knowledge base. There were some few talks actually in the conference itself. I think Trey from Lucidworks, actually, he talked about some of the knowledge graphs. But having a knowledge base is very critical to do any query intent. How you can build a knowledge base, you can have your own domain catalog, you have own domain taxonomies, which you can use. What we use user query logs, and we use that query log to determine what the results was clicked, and for that result, what the purchase was made. So that's a very, very strong signal we have. Oh, for this query, this click happened and this sales happened. When you have a sales as a strong signals, then that's query and that's entity is very, very critical. So what we do actually, once you type some certain queries, then we actually break those query. That's what we call a query segmentations. We break those query into a semantic units. What the semantic unit is basically converting into with the one or multiple tokens which understand the meaning, not just a string. So that's where another approach was like entity detections, which we use actually, which elevates searching from traditional query terms to a thing, right? What's the meaning of that term means when people type San Francisco Giants, is a team name or is the city name San Francisco and the Giants? So how do we determine that way? And once we have those query scope defined, then we actually do our query rewrite. And the query rewrite, actually, we have just a simple rule base and the pattern base, actually, of certain queries, how we do a rewrite. And I'll go over the next one, actually, to show you how technique. So here you can see, actually, we have a Solo, actually, where we keep all the query logs. And the query log actually is broken down by a geohash. So it has keywords, it has the performer or the entity IDs, and it has a lat long, and it has locale. Locale actually make sure to support, we can support multiple language. And this is the query logs, which has shows, which we capture from our production query histories, which shows for each query log what was actually the purchase was made. And we keep it in the local cache just to improve the performance, because when the people are typing the query, the detection should be happen very fast and quick. So the query example was like, Giants game this weekend. So if I send this query to Giants game this weekend to a regular search engine, I will not get any result because they don't understand what Giants means. So what we do actually, we look at this, we actually phrase these tokens like into single terms and the multiple terms. And we ask our knowledge base, okay, is this, what this query term, what it entitled to purchase? So which has actually the attribute of what the artist or the team is. Once we identify that, then we actually, what we use, actually, we just boost those performer and send to the search results. So when the search results come, before the search results, so we do the query rewrite. So the query will go to search engines like, instead of Giants this weekend, it will go to Giants game. And this weekend will be transferred into rewrite into some date filters like for this weekend. What was the date range for this weekend is?
Now, how do we measure like we don't know whether we are really being successful in our quest, right? So the typical standard search metrics get applied here, right? Precision, recall, and normalized discounted cumulative gain. Our goal with each one of these metrics is to get them closer to 1, right? So for NDCG scoring, we actually employ a team of human graders, right? They actually subjectively score each of the results on a scale of 0 to 3, 0 being the least relevant, 3 being the most relevant. And then based on that, we compute the normalized discounted cumulative gain score, right? Again, our goal is like, the closer it is to the human ranking, right, the better it is going to be, right? So pretty standard metrics. And for operational metrics?
So operational metrics is also, I think, pretty standard. Most of the people, how much query volume you want to support. For us, actually, is we have many clusters in the productions. We support like almost 120 million queries per day, and it's like almost 1,000 queries per second. So we have many clusters as I said, in the production. But our goal is like, if the query is not fast enough, people will not actually entitled to further move forward from the search results to the and buying anything. So our goal is to making sure our query response time is less than 100 milliseconds, most of 90% of time. And as I mentioned earlier, also about our data change in terms of the pricing when somebody buys a ticket, because in the event world, a seat is I cannot sell actually these seats to somebody else because seat is very unique for a particular event. But in e-commerce, if I buy an iPhone or something else, if it's not available, they can actually buy from some other thing and they can sell you. But seat is a unique. If I sold this seat for you, I cannot sell to anybody else until you resell those tickets on our sites. So the data refresh time is very important. So what we have like 2 to 5 seconds refresh time, which is pretty much same as Solar Soft Commit we use. Yeah, that's the next one.
So now machine learning at StubHub, right? Now how do we use machine learning? So for one, right, I would like to point out that this is a proof of concept that we have built. It isn't in production live just yet, right? The goal with machine learning is to predict the metadata associated with each of the events. By that we mean, so today our catalog team, they go in there, right, and they create the keywords that should be associated with each of these events. It's a pretty manual process, right? And the problem with this approach is that how do we scale? So as I mentioned earlier, StubHub wants to scale into 40 different countries. When we say 40 different countries, the event will be in multiple different languages in each of these countries. So now to associate the keywords for each of the events in those languages, it's a challenge, right? But the bigger challenge is how do we know what keyword to associate with each of these events, right? One way is to guess, right? We think, right, that the name, the venue, right, all these things should be associated, correct? That's a simple, straightforward thing. But the problem is that users don't always search with the same thing, right? Like for example, if they type in Tom Brady, what should I show? I have to be able to show New England Patriots, right? Now, how do we know that Tom Brady should be associated with the Patriots events, right? So for that, what we have done is, we have used a machine learning method, right, for which the training data is what you see on the left-hand side. So one is our training data is very, very straightforward, whatever we have in our catalog words today. The second training data is the search terms. So the search terms that led to the click of these events and to the purchase of these events. So what we do believe in is that when you type in a particular query, the users would somehow find the event that they are most interested in, and then they will purchase it. Just like in typical e-commerce, right? You don't find the product that you're looking for, but then they would go to navigation, browse for that product, and then buy it, right? So same way here, right? If they didn't find it, they would probably browse for it, find the event, and then they purchase it, right? So that search term gets associated with that event, right? And the probability is very high. And the third part is Rovi data. So we partnered with Rovi, and Rovi provides us with information about the entity. So for example, Rovi could provide us with information about the New York Giants, who the coach is, where do they play, what their home field is, right? Things like that, right? So we extract all this information, we pass it through our machine learning algorithm, right? And then on the right-hand side, what you see is the output, right? It's a much cleaner set of output, right? The goal again with this machine learning engine is to predict the most relevant information for each of the events. So how do we use it, right? So now when the user conducts a search inside our search engine, we have to be able to produce at least the same set of events that we produced previously, correct? What that really means is recall should exactly be the same. Let me give you another example here. I used to be at Williams-Sonoma, and the user would type in whiskey glasses, right? The number of results retrieved by the Endeca engine would be 2. Why? Because Williams-Sonoma sold 2 whiskey glasses, meaning that the merchandisers had actually put the word whiskey glass with only 2 of the glasses. Williams-Sonoma as a company does not sell glasses that are used for drinking water. They only sell alcohol glasses. But the glasses were marked as double old-fashioned crystal glass without the word whiskey in it, right? So clearly they would never be retrieved, right? So the hard thing there was how do you come up with all these keywords that need to be predicted for those products? So therefore we relied on our search engine, right? So people would actually search for this, they will not find it, great. But then they would, in the same searching session, they would actually go to the browse and then purchase the same thing. So now we have a strong association, right? Similar concept here, right? We want to be able to predict the most relevant keyword for that particular event, right? I mean, there's a whole lot of probabilistic matching that is going on with these things, right? Because the probability of this particular keyword being associated with this particular event has to be over 90%. So the predictor's interval, right? It has to be very, very tight, right? We have to be able to predict correctly. But more importantly, when we measure the results, the recall should be close to 1. The precision, the number of relevant documents retrieved, should be very, very high too, right? So this is a proof of concept. We have not moved to production just yet, but will be soon. Next up is Chatbot. So StubHub as a company launched a chatbot about a year ago. The goal with our chatbot is very straightforward. We want to build a chatbot that allows us to have a human-to-human interaction and then allow the users to find the tickets and then complete the purchase. Now our chatbot is available in Skype, it's available in Facebook, right? And the reason for that is Facebook has about 2 billion active users, with Messenger having about 70 million unique a day, So we want to be there where the users are, which means that our chatbot is present in Facebook. So now when the user enters things like top events in San Francisco, that's a very straightforward query, right? But what if the user entered a query like, give me the Hamilton events in Houston over the next weekend? Oh, and by the way, the price range should be like, less than $100. It's unlikely that you will find a Hamilton event for less than $100, but the system should be able to understand that part, right? So we built this NLP engine, right? Earlier, Gopal gave an example about like, Giants game next weekend. Query is very similar, right? Earlier, when you would type in Hamilton next weekend, you would see 0 results. But on the right-hand side, you are able to see results for Hamilton next weekend. We made this query a week before. So the system is able to understand that Hamilton is an artist, right? It's a theater. Next weekend is actually the date, right? Now you could technically type in next weekend before Hamilton, in between, Hamilton and Chicago, right? You could type in anywhere, and the system should be able to recognize that part. We are working towards that type of a system. So what we want to do is to replace the existing NLP engine that we have today with our chatbot with our own homegrown engine. We want to run an A/B test and then figure out how do we get there. So this, and then the next one is just our screenshots, right? How our chatbot looks. This is the Skype version of a chatbot. We launched in Skype before we went to Facebook. It's a very simple thing. Top events in San Francisco, right? You get this list, right? And then you can actually select this particular option. But this is precisely what we want to replace. It should purely be conversational. And then that's our goal. And how do we get there? Is using our NLP engine. Next up is like, what is our current architecture in solar? And what was before, and what is our future?
So one of the things in the beginning I mentioned that we are using Solar as a search engine in the StubHub for quite a while, from 2010, from the version of like 1.2. So we we have seen the different phases of the Solar versions and the features it supports it. And traditionally we had like a master slave options, and which. So in the beginning, like in 2010, actually, what Solar actually helped us actually to improve, provide a search capability to our site, plus provide an API program for our all external partners and brokers. Because just putting our catalog in the search engine, it helps us to actually, how we can actually leverage our catalog to our affiliates or the other entities, so they can actually sell from their site too. So in 2010, actually, we were able to do that from the Solar. As you can see, we had a master slave. Then after a few years, we had a use cases for more search, not just a full text search, but search with more analytics queries, more about the NoSQL solutions. So earlier, nobody thought actually search could be used as a NoSQL solution, but at StubHub, we use some of the use case with the NoSQL solutions, but the requirement was hard actually. If it's a NoSQL solution, but it has to be a near real time. But Solar did not have that feature until Solar 4.0 came like a few years ago, right? And I think that was the longest period any of the Solar version took to release. As you can see, a lot of Solar versions get released a lot quicker, but for Solar Cloud, it took a while. But so what we were doing actually at that time, actually, we were able to actually use just a nightly build of Solar Community, and we were able to run like a nightly build for almost 7-8 a month in the production. And I think it's to the kudos to the community, the quality of the code, and it's so good you can actually run in those productions. And so what that time we just used the patch version of the near real-time approach of the soft commit to our systems actually. But the challenge we had in this one actually a lot is like consistency of the data between each node. As you can see, the data get fetched from the source and put into the index, but each node does not know whether they are consistent with each other. So we lose a lot of time data. And I was mentioning if you lose the data, then a seller or the broker or the buyer cannot see those tickets. And if they cannot see those tickets, they cannot buy it. So then our happy world was Solar Cloud. We were happy, we saw Solar Cloud. Solar Cloud has solved tons of our problems, especially the configuration system itself managed by Zookeeper, And then anything we need to do between, we don't have to additionally, in the previous version, we have to add additional process to check the consistency between each node, whether the data between node 1 and node 2 is consistent always. But with Solar Cloud, that's all those problems actually taken care. And whenever we need to add any new index, actually, there was a manual process of operation team, rebuild the index, create those index, make those index available to active. In the Solar Cloud, we use collection alias. We build online index and offline index. So we can do all this index building in real time. So our indexing time itself actually was like in days, actually, before the Solar Cloud. Now it's like in like 15 minutes. 15 or 20 minutes. So we can rebuild the index anytime. We can switch the index on the fly with the collection alias. That's actually the best part was. And in terms of the data fetch, our indexing pipeline does not use like a Solar inbuilt DIH. We have our own index process where we use standard mechanism of date last modified, how we fetch every few seconds. But the key in this whole pipeline is like, you should not lose the data actually anywhere. If you lose the data, then how do you know where the data is missed? So that was the key part was that. And earlier version of the Solar, we have people actually use Solar directly, but we had a lot of challenges. People, whenever we want to do upgrade, they are using Solar this feature, we cannot do upgrade. So in the new version, we made sure, everyone use the API, and actually API delegates to the Solar query. But there are some other use case of the internal, you cannot use API because API adds a little bit overhead. So there are certain use cases for in our team, like recommendations, or they use Solar directly. So we have a driver, like a native Java library, build a wrapper around on those APIs.
So this is our entire presentation, right? We would like to open the floor for questions. Does not seem to be any questions. Sure.
You mentioned the Tom Brady example, and I think you kind of hit this, but with Rovi, that's the way you see, this other metadata you really don't know about, or maybe as well the fact that they entered that, but then you captured that and through the browse session, they executed the order. Is that? Am I getting that right?
Yes. So the question is, how, if I'm understanding the question correctly, right? Right. How do we get the relevant metadata in one of our training data sources, right? So one option to always get the training metadata is to rely on your own internal sources, right? The internal sources are always your own humans, right? Who are entering the catalog data manually. The second one is, your users who are actually searching for something, and by browse experience, somehow they are able to figure out the correct event that they wanted to go to. But the third important source that we felt was, we partnered with Rovi long time ago, right? And that data is extremely useful for us, right? So that data actually gives us information about the artist, about the teams, right? And we bought that data and we partnered with them, right? So we want to use that data to make meaningful associations between like Tom Brady and New England Patriots. Rovi is one of the sources, right, that we have as we scale into different countries. We could potentially partner with other vendors who can actually provide us with relevant information about international events. So that is another option, right, to go with, because internationally when you speak, they generally have a lot of slang in their languages, right? And that is the hard part. So, how do we associate that slang? How do we know? How do we formulate the word associations? How do we predict the next word? Because one of the challenges that we had with this whole machine learning system was new and York would be two separate words. So in one line you would see new, and the second line you would see York, right? So if the user types in new, we might actually show New England Patriots and New York Giants all together in that same list of results. So we had to join the words together too. So, yes, there were significant amount of challenges that we noticed when building this particular system. Any other questions? Great. Yes. Right. So for each, so the question is, how do we associate the Rovi data with each of the events? So Rovi actually gives us the information about the team ahead of time. So imagine a simple Excel spreadsheet, right? And on one column you actually have something like New England Patriots, and then in column B you will actually have Tom Brady, and a whole bunch of other names or places like Super Bowl 5, Super Bowl rings, 5 Super Bowl rings, 6 Super Bowl rings, right? The last team that they won against, right? You would have all this information separated by comma, right, in column B, right? So this association is given to us as a training data ahead of time. We do not associate that part.
So that's why we try to use the source like a Rovi, and even like, so seeding is always a challenging problem whenever you want to seed the data. If you don't have a history, like example we are doing like machine learning, right? So when we want to do a machine learning, but how do I generate the training data? I don't have machine learning infrastructure to generate the training data. So even then we came up with, okay, to generate the training data, maybe, okay, let's come up with some sequence of the patterns, the queries we want to support. And so that will generate us some of the training data. Now we have a training data, but how do you educate our user? You can search in natural language to our site. Because user is actually used to search in one way. They don't know actually how. This is also is possible, like Giants home game next weekend I can find, or Giants game, Giants versus Dodger for $40 tickets I can find actually. So what we decided the approach actually, or how about actually we have a type 8 suggestions. So if people type Giants, why we could suggest Giants versus Dodgers at $40 ticket. So that's how we try to educate the user. Okay, you could actually search more broader way than just regular simple team-based search.
All right, great. Any other questions? Thank you guys for coming.
Thank you.